My name is Manraj and my entry number is 2021CH10403 and I am here to present my ELL project in front of you. So what I'm going to discuss here. Let's say we have so many household equipments and future building gadgets. Everything we know that works on electricity mostly works on AC current. But what if all the sources were DC sources? What will happen then? Will we be able to access those appliances that we use now in daily life? Looking over the solar panels, which are important sources of renewable energy and hence making the future, they collect every amount of energy in the form of DC and also supply them as DC. But without a certain equipment, can we use applications, the appliances that we use in daily life? It is certainly not possible, right? Moreover, in certain countries which are developing, or say a certain years ago from now, there used to be a lot of power cuts, but these devices along with batteries made coping up with these power cuts easier. So, what am I talking about? Let's look forward to know. The topic that I'm going to discuss here is an inverter. So, what is an inverter? Inverter is a device that changes DC source to AC supply. After learning what is an inverter, one may ask that what is the need to convert DC to AC and why we need such a device in the first place. To answer these problems, the solutions lie in our daily life prospects. The household prospect, where we know that the appliances that we use day to day needs AC supply to work, and the industrial prospect, which focuses on transporting electricity from one place to another. But this would not be possible if there was only DC current and if everything was carried out through DC. To go with my argument, I would like to explain you Joule's law, which is E is equal to I square RT, which explains that the more the current, the more will be the heat loss in that wire. In the form of DC current, this inefficiency is high, but in the case of AC current, the voltage is amped up and hence the energy loss can be reduced. So, how do we make an inverter which converts DC to AC? Since AC is a much needed thing in our life, so we must convert DC to AC. But how do we do it? If we have learned some basic knowledge of AC, we know that AC is generated by moving a coil in presence of a magnet on both the sides, and the changing fluxes due to the Faraday's law in turn induces some voltage in it which has a shifting phase. So inversely, to convert AC from DC, we can do the same by rotating a motor in front of two magnets and convert DC to AC. But is this all the solution that we can have? Let's look over. Was this all in an inverter or it could be a little bit more technical? The answer is yes, it can be more technical. During the late 19th century, scientists were working on more efficient inverters and the age of diodes had arrived. A new era of inverters was going to start with the help of rectifiers. After learning about this fact, you may ask that what is a rectifier? So, in simple terms, it is a device that converts AC to DC. Now the question arises, why do we need this if we had already an DC to AC generator? So, the components of the rotatory inverter may incur damage in prolonged amount of use and due to heating it is very inefficient. Due to these advantages or disadvantages of rotatory inverters, we need to come up with something that was more efficient and more compact. But there arises one more question, that a rectifier converts AC to DC, but here we have to convert DC to AC, right? So What is the solution? The answer is yes, we need to convert DC to AC, but here the concept of conversion of current is what makes things interesting. Let's dive deeper into how a rectifier works. A rectifier is a combination of diodes in a circuit which open and closes in such a way that when the AC current in one phase, certain only certain diodes are open, and when it is in the other phase, the other two diodes are open. This helps in maintaining a steady current and hence making a DC current source. This is how a rectifier works. Pretty simple, right? With help of this concept, we can learn how power inverters work. So, power inverters, the diagram of simple power converters is shown in this figure. Here, the IGBTs refer to the transistor which acts like fast opening and closing switches. They are arranged in such a way that the alternate keys are flipped from open position to the closed position in such a way that DC flows from the source to the battery in firstly in one phase and the secondly in second phase, giving it two directions and making it an AC current like source. But if you think, is this enough to light up or say use all the equipments in house? The answer to the previous question is no, it is not enough because in electrical use, appliances usually work on 200 volts or higher, while the DC source simply being converted to AC will not suffice. So, what extra component will we require? A device that can step up or step down the voltage. Mo Most of you must have guessed it till now. Yes, I am talking about a transformer. Also, if you are thinking about the pattern that we will obtain from that converter that we saw in the previous slide, so that would not exactly represent the AC. But in order to represent the AC wave pattern, we use pulse width modulation, which we will discuss sometime later. So, what is a transformer? So, a transformer is a device that is used to amp up the voltage or step down the voltage in order to make it usable for certain types of conditions. So, how does it work? A soft iron core is wrapped around with the coil having some number of turns on either side. And when a source or supply is connected to the primary coil, it induces current in the secondary coil due to the Faraday's law or magnetic induction, and giving us the relation E1 by N1 is equal to E2 by N2 is equal to K. This short clip, or say the GIF, represent how a transformer works. So, what we have discussed till now. In order to convert DC to AC, we need inverters. An inverter consists of two components. Firstly is DC to AC converter, which works on IGBTs and opens and closes the switches so fast that we can have the direction in two directions, which can be used to make AC current source, and a transformer which is able to convert the voltage into usable voltage. So, what are these inverters useful for? In developing areas, there is a certain need of a constant power supply, but it is not available. Due to this, many things get interrupted. But if a person has a battery and an inverter, it can store the energy in form of DC in battery and then harness it with the inverter and light his household when the power supply is down. Also, the solar panels, which store energy in the form of DC, we need inverters to convert that DC into AC and make it usable. So, this was all. My name is Aman Raj, and thanks for watching.